Welcome to class. We are still in the concept of linear combination in R to the power of n. In the last video, we talked about when n assume the value of 1. Now, we will talk about when n assume the value of 2. Now, this is the expression we're talking about, and we know that this R represent the set of real numbers, and this n here is the exponent, and this exponent n belongs to the set of natural numbers, and we know that natural numbers are positive integers that starts from 1, 2, 3, 4, 5, and to infinity. In the last video we talked about the expression, what the expression gives when n is equals to 1. Now we will still look at what will be the outcome of the expression when n is equals to 2. Now if n assumes the value of 2, you see that this particular expression will become r to the power of n equals to 2, and this gives us r2, and r2 is the same when r multiply r. Now this happens in 2 times. This means that r multiply itself twice. Now what is r to the power of 2, which gives us r times r? This produces what we call a product of set. And this product of sets is same as when you talk about the Cartesian product of a real number and real number. Now this particular set is defined as the set of different ordered pair. The set of different ordered pair. This set is called the set of distinct or different ordered pair. And when we talk about ordered pair, this is how ordered pair is something written like this. When we talk about ordered pair, we talk about this particular thing. Now, in this ordered pair, A here is called the first element, while B is also called the second element. Now, how do I describe this once more, this particular set? Now, so long as set so long as the term set is employed in this definition, and whenever we're talking about set from the elementary system, we must employ this particular symbol called brace. Hence, how do we define this now? Now, r squared, which is r multiplying itself, we are told that this particular set is the set of distinct ordered pair. This is distinct ordered pair. Now we have this set, we employ the brace, and we have the distinct ordered pair. Now this distinct ordered pair, the first element must belong to the set of real number, and the second element must belong to the set of real number. Hence, this is how we define this, such that A and B belongs to real number. Now, looking at this particular concept, we can still talk more on the geometrical concept of r to the power of 2. Now, r to the power of 1 filling a line, r to the power of 2 filling 2 lines. Now this is a real line, and here becomes 0, we have the down and the upside. This upside, we call it positive value. Let's call here 1, let's call here 2. Here is positive real numbers, and this downside is called negative real numbers. And here is a real number R, and at the same time I'm still bringing another real line, and if I extend this line to this other side and extend this line to this other side, here we still have a real line. Let's call here 1, and let's call here 2, let's call here -1, let's call here -2. Now you see that for any value, this is real line, for any point here, there exists 2 particular points. For any different points, this point is different and this point is different. For any different points, we can trace this point via this particular line, and let's call here x1, we trace it, let's call here x2. For this particular point here, we have x1 and x2. At the same time, when we have this point here, we can trace it down. We have y1, at the same time we have y2. So we call this point y1 and y2. So this real number to the power of 2 implies an ordered pair. This is how we employ the ordered pair in this definition. And you have to understand that for each element, let's call the element x bar. For each element x bar in this R to the power of 2, there exists x1 and x2 element of real numbers such that x bar is equal to the ordered pair. And if I should make a point here now, if there is a point here, let's call this point Q. You see that we can trace this point from here, and let's call this point A1, and let's call this point A2. You see this point is being ascertained by 2 particular points A1, 2 particular points on the real line A1 and A2. We'll call this A1 and A2. Hence, for each value x in R to the power of 2, there exists x1 and x2 such that this x bar is equal to the ordered pair. Thanks for watching.